Section 12.6, the first part, solve exponential equations. All right, so now we've learned all of these properties so that we can actually solve equations and find out what the x is. That's the name of the game in algebra. Here we go. So here's some last properties that you need to be sure that you know. If you've got two bases that are the same, raised to exponents, then you know that those exponents must be the same. And by the same token, if you've got two numbers that are the same, if you raise those, if you give them the same base, they're still going to be equivalent. All right? Same happens with a log. If you've got two different numbers to the same log, and they're equivalent, well, then they're actually not different. They're the same. All right? Same thing if you've got an x equal to y, you can take the log of both of those and the log of this with the same base of both of those, and they stay equivalent. Remember, if you do the same thing to both sides, everything stays the same. And this property you already know. If you have log base b of x equals y, you know that the base is the base, the answer to your log is your exponent, and the number you're taking the log of is your other side of your equal sign. All right, it's your value. All right, here we go. So what we want to do is we want to solve equations such as this. We've got 5 raised to the x power equals 16. And what we've done in the past is we've made those have the same bases. But 16 does not have a factor of 5. So it's not going to work in this case. So what we're going to need to do is use one of our handy dandy little properties and say, well, I could raise both of these to a log, and I could say this is log of 5 raised to the x power equals log of 16. And now when I do this, this power now becomes out front, and now I have x times the log of 5 equals the log of 16. The reason I did that is now I can get this x by itself. I can get it by itself by dividing by the log of 5, because now we're just multiplying these. So if I divide both sides by the log of 5, then I keep them equivalent. And I get x all by itself. And now what you'll have to do in this case, log of 16 and log of 5, just put those into your calculator. So 16 log equals divided by 5 log equals should get you roughly 1.7227. So go ahead and practice that. Try that on your calculator right now to make sure, because it matters where you press that equal sign, okay? So what you'll do is you'll press 16 log divided by 5 log and then press equal, because 5 log will give you the log of 5, and then you press equal and it'll actually divide them. And that should give you 1.7227. All right, so now let's do the same type of thing. Watch this. The same type of thing if we have e as a base. Now remember, e was the base of our natural log. So what we could do in this case is let's raise this to the natural log. So ln of e to the 4x equals ln of 23. Now, this is why I did this, because watch this. We could, okay, so now bring this in front and all of that, but do you remember the natural log of e, the base is e? And do you remember when you have a log base something to the same something of the same something, if these two things match, then all of this is equal to simply the exponent. Do you remember that from a section or two ago? So now all of this just equals 4x. All right? So 4x equals the natural log of 23. All right? So all of this, the reason I raised it to the natural log was so that I could eliminate this e and not have to deal with it. All right? Because those will cancel out now. And now this is 4 times x. To get the x by itself, I simply divide by 4. And when I do that, and this is going to be another approximately equal to, because put into your calculator 23 natural log, the divided by sign divided by 4, so 23 natural log divided by 4 should get you 0.7839. So practice that right now. Make sure that you get that same answer, and then you have you've done the correct sequence of numbers. All right? Now, there are several like this in your homework where either you need to raise it to a log base 10 or a log base e, or a natural log. And so either of those will work. All right, what happens then if we've got all of these logs already? Okay, it doesn't help us to raise something to a log if we've already got the logs. Well, do you remember all of those properties that you learned about, well, if we're adding two different logs, remember we're just multiplying. So this, first simplify it as much as you can. So this is log base 5 of x times x plus 3, right? Because this is adding the two different logs. So now since it's the log with the same base, instead of adding both of those logs separately, what I can do is combine them together and multiply what we're taking the log of. All right, and that's still going to equal log base 5 of 4. Now, check this out. We have a log base 5 on this side and a log base 5 on this side. These are the properties that I just showed you. If you've got the log to a base equals the log to the same base, if you're taking the log with the same base, then that's the same as just what you're taking the log of. So if these two things match, it's almost like they can cancel each other out. It's almost like you don't really, but it's almost like you can divide by that and get rid of it. So then this can be just x times x plus 3 equals 4. You see how that worked? All right, so x times x plus 3 equals 4. Now that's a simple problem to solve. Simply distribute through, so x squared plus 3x equals 4. And now because we have a squared term, we're going to end up wanting to factor it, so get it equal to 0. Subtract 4 from both sides. So x squared plus 3x minus 4 equals 0. Now we've got a trinomial. So factor it. X times x is x squared. The signs are different. I want to multiply to get 4 and add to get 3. So 4 times 1 is 4, and 4 minus 1 is 3. So that all equals 0. So one or the other of them has to be equal to 0. So x plus 4 equals 0, or x minus 1 equals 0. And I'm standing in front of it. So you're going to subtract 4 from both sides. So x equals negative 4. Add 1 to both sides. Negative 4 or 1. Easy sneezy? All right. Once you get rid of those logs, it actually becomes just like what we've done, just the factoring that we've done and the solving that we've done. Okay, what if we've got a log, but the log is only on one side? Now how do we solve it? Well, now let's use this last property. So let's take the base of 3 squared equals what we want to take the log of, because all of that is in parentheses, so it's the whole thing. So once again, we have a simple, now we've gotten rid of the log. Now it's something that you can do. The x is not in the exponent. You don't have a log. 3 squared is 9. 9 equals 2x plus 5. So get the 5 on the other side, subtract 5. So 4 equals 2x, divide by 2, and x equals 2. 4 divided by 2 is 2. Easy sneezy. Let's do one more. This one's a little bit trickier. Here we go. But not too hard. We can do this. Okay, so once again, we've got 2 logs here on one side, but we're subtracting the 2 logs. So remember, if we're subtracting, now that becomes a division problem. All right, so let's divide it out. So this is log base 2 of 5x plus 1 divided by x minus 1. All right, and that still equals 3. Okay, so now how does this help us? What do we do? Well, once this actually kind of looks like one of these, but it's just a little more complex. Let's see if we can get rid of the log this way. Can we say 2 cubed equals 5x plus 1 over x minus 1? We certainly can. All right, and 2 cubed is 8. So now 8 equals 5x plus 1 over x minus 1. Now, if you'll remember, when we have something in the denominator, we can get rid of that by multiplying both sides by that denominator. So let's multiply both sides by x minus 1. And that gets rid of the denominator on this side. And now we're going to have to distribute that through. So we end up with 8x minus 8 on this side, because 8 times the x and 8 times the 1. So 8x minus 8 equals 5x plus 1. Now it looks pretty simple, right? Add 8 to both sides. So 8x equals 5x plus 9. Subtract 5x from both sides. 3x equals 9. Divide by 3. Ta-da! X equals 3. Not so bad at all. All right? So the trickiest thing is going to say, well, what is my plan of attack? What do I do first? Do I need to raise things to a log in order to get, if you've got the x in your exponent, then probably you're going to need to raise it to a log. If you've got logs involved, look to see how you can simplify. If you've got logs only on one side, you're probably going to use this format where you take the base raised to a power and you'll get rid of the log that way. If you've got logs on both sides, then chances are good that you can combine things enough to where you can get rid of the logs. All right, so it's kind of three different types of ways to solve these. Good luck. See you soon.